McDonnell Douglas aircraft explore the skies of the world with perfection. With excellence, they bring men back from the edge of space to fly again. Much of the credit goes to the men who ride them. But the craft they fly are symbols of perfection, the end result of thousands of hours of quality work by members of the McDonnell Douglas team. The key is quality, and this is how it's achieved. Through these doors pass the most meticulously inspected aircraft in the world. At McDonnell, we call it quality assurance, and it has become a way of life in the production of the world-famous Phantom fighter bomber. In fact, quality in all our products is an obsession with us, and this demand for perfection transformed a simple inspection operation into the highly complex and specialized quality assurance division as we know it today. Staffed with more than 7% of the total plant population, the division ensures that materials, processes, procedures, supplies, and services meet all formal specified quality standards. In the fulfillment of this responsibility, McDonnell quality assurance activities cover the receipt of raw materials to the expenditure or obsolescence of the customer-owned end product. The Quality Assurance Division acts as the principal corporate instrument of internal self-criticism with regard to quality standards. But inspection and the discovery of imperfections is only one part of the division's function. No longer can quality assurance people sit back and wait for flaws to pop up in the manufacturing process. Now they try to root out problem areas long before faulty components can show up on the assembly line. Using carefully planned preventive measures, they take steps to correct potential trouble spots before they can grow into major problems. From the cradle to the grave, as they describe it, quality assurance people keep their fingers on the pulse of every product. They nurse them to perfection and keep them healthy from design to obsolescence. Much of the examination and diagnosis of a product's physical condition begins with its arrival at the plant. But for many of these raw and semi-finished materials, this is their second encounter with McDonnell personnel. Teams of quality assurance people already have visited the plants where the materials were born. The outside production quality assurance department monitors the quality operations of thousands of suppliers located in virtually all the 50 states and various foreign countries. These suppliers must measure up to standards established by McDonnell quality assurance experts before their products can be shipped to St. Louis. Another example of preventive steps taken early in the game to assure high quality. From the receiving area, these products are channeled into appropriate testing areas for inspection. Many of the new materials and components feel the eye of the X-ray and the sound waves of ultrasonic equipment as they probe for hidden flaws and weaknesses in the material. Others undergo rigorous testing in laboratories equipped to put pneumatic, hydraulic, and electrical components through their paces. These laboratories are manned by quality assurance experts who take pride in their ability to spot a faulty component and intercept it before it can find its way into a product. Another eagle eye in the quality assurance system is the mechanized fluorescent penetrant inspection process. Developed by McDonnell, this system features monorail conveyors which move parts through a complex process that uncovers the slightest flaw in their makeup. The parts are bathed in a penetrant oil as they are carried through the system in wire baskets. When they reach the inspection booths, the parts are scanned under ultraviolet light. Any surface imperfections quickly appear as green streaks that follow cracks or other flaws in the part. Also in this area, ferrous materials are tested by the magnetic particle method. In the field of quality assurance, they say if you can't measure quality, you can't control it. The guardian of dimensional, pressure, weight, and optical measurement accuracy at McDonnell is the metrology laboratory, one of the finest equipped facilities of its kind. Enclosed in double walls in a dust and vibration-free environment of precisely controlled temperatures, technicians calibrate more than 1,000 measuring devices daily. Some 20,000 pieces of measuring equipment periodically pass through the metrology laboratory, where many are calibrated to within 3/millionths of an inch of perfection. With a computer-connected laser beam, technicians conduct long-path dimensional tests of dimensional measurement equipment. The laser replaced cumbersome and less accurate equipment with space-age precision. Optical instruments used in the McDonnell tooling program are calibrated in this optical collimating test stand. Another tool of the metrologists is the fringe count interferometer. This complex instrument measures gauge blocks, determining their dimensions by using wavelengths of light. Pinpoint accuracy also is the word in another quality assurance department, tooling inspection. These men are responsible for the accuracy of all tools used in the fabrication and production of quality products. New tools must pass an inspection before they are used, and they are periodically re-inspected by tooling experts at established intervals. When a tool passes its inspection test, it is stamped with an inspector's seal of approval, the mark of excellence it must wear before it can be put to work. Quality products are born not through inspection procedures alone, but through scientific analysis and examination of the materials, processes, and equipment which control their manufacture or become a part of them. The laboratory consists basically of two sections, chemical and metallurgical, and its technicians painstakingly test everything from nuts and bolts to paints, sealers, and oils that are used in the manufacturing process. It is in these labs that the philosophy of quality assurance is graphically portrayed. Using highly sophisticated equipment, these technicians probe, analyze, and examine in an exhaustive effort to ensure perfection in the finished product. But the demand for quality doesn't begin or end in the laboratories with the detection and prevention of imperfections. The quality planning department is the primary source of information in the intricate chain of procedures that assure quality products at McDonnell. This department aids in formulating inspection instructions and in the development and improvement of methods used in assuring quality. Quality planners see to it that inspectors have the instruction manuals and other material to back them up in their intensive search for perfection. One of the prime responsibilities of quality planning is the distribution and control of the inspection stamps used by quality assurance personnel. The serialized stamps, which are the inspector's personalized marks of approval, can be traced through quality planning records to ensure their use by only authorized inspectors. At McDonnell, these highly trained inspectors check and double-check the company's aerospace products from design to delivery. All along the line, as the supersonic Phantom fighter bombers take shape, exacting inspectors follow detailed checklists as they verify that production workers have built quality into the big jets. The importance of these inspectors cannot be exaggerated. They are backed up by weeks of training before they are qualified as inspectors. Under the watchful eyes of full-time instructors, they may spend 5 to 10 weeks in classroom instruction and on-the-job training during this grooming period. But even before they are accepted for training, the men and women are carefully screened and tested to see if they measure up to the high standards set by McDonnell for its inspectors. After acquiring additional experience and seasoning, many continue their in-plant training after becoming inspectors to qualify themselves for upgrading as well as supervisory positions. One of the critical links in the chain of quality inspection checks out the complex electrical wiring system of the Phantom. Using automated circuit analyzers, inspectors trace the more than 13 miles of electrical wiring that is the nerve system of the supersonic aircraft. With these machines, inspectors can pinpoint an electrical malfunction in minutes and trace it to its origin for repair. Including the intricate hookup of the analyzer to the airplane, this examination of the jet's electrical health covers an 8 to 17 hour span. At another station on the McDonnell line, the Phantom faces another rigid test.
All clear. Flaps up, John. Flaps up.
This one is called the functional operations check, and it takes 3 inspectors 8 hours to put the plane's electrical, hydraulic, and mechanical systems through their paces. It is here that the Phantom first flexes its wings, literally, as mechanical and electrical inspectors test the operation of the folding wings. Specially calibrated measuring devices check the travel of the aircraft's movable wing and tail surfaces, as 2 inspectors, linked by an intercom system, work together from opposite ends of the airplane.
Full nose up. Okay, now trim it. Full nose down. You're down.
Still suspended above the floor, the plane stretches its legs for the first time as inspectors flip the landing gear in and out of the wings in a relentless check of the hydraulic system. The gear must nestle into the Phantom's wings in a snugly tailored fit, and it's the inspector's job to make sure that the required clearances between the gear and a maze of hydraulic and electrical lines is maintained. All along the final assembly line at 51 stations, quality assurance inspectors supervise the closing of more than 200 doors on the aircraft. The panels are bolted into place only after the inspector is satisfied that the area they cover is error-free. Then the inspector puts his stamp of approval on a seal overlapping the edge of the panel, and it cannot be opened again without breaking the inspection seal. Any broken seals require re-inspection of the enclosed areas prior to inspection release of the aircraft. Almost 1/4 of the 200 door closings come during the pre-ramp inspection, where more than a dozen inspectors swarm over the Phantom before sending it into the outside world for the first time. It is here that the inspection process is even more rigorous than any the big jet has faced so far. For the Phantom now needs little more than its engines and a dressing up with paint to ready it for flight. But with its engines aboard and its skin painted, the F-4 still must pass another stiff examination of its electronic system. Teams of inspectors and technicians follow step by step a master station book compiled by the production planning department. As each check is ticked off, the inspector stamps his mark of approval in the book. Over a 5-day period, these men will devote 240 hours to each aircraft's electronic system. Half of that time will be spent on the Phantom's automatic missile control system alone. Now the big jet is just an engine checkout away from taking to the air. But the big bird still must run another gauntlet of inspectors before it is pronounced ready for delivery. Test pilots and quality assurance inspectors, using computerized information, work closely to ferret out any quirks in the plane's personality before it is turned over to the customer. And even after delivery is made, members of the Quality Assurance Division keep close tabs on the performance of the aircraft. These engineers are trained troubleshooters who act as a sounding board during periodic visits to customer facilities. Through the liaison work of these engineers, the cradle-to-grave quality philosophy at McDonnell is carried to its ultimate conclusion. But tracking down imperfections is only a beginning. What happens once these flaws are uncovered by the inspection experts? Nonconformances are documented and controlled under the McDonnell Materials Review System, another responsibility of the Quality Assurance Division. These reports and related data from all sources are channeled into the quality engineering automation. This results in timely review of all potential quality problems. As soon as a problem is reported, quality engineering steps in with a review of the non-conforming components and a program of failure analysis and corrective action. Specialized investigators are assigned to seek the cause of the malfunction and to come up with ways to eliminate it. When corrective and preventive measures are established, quality engineers ride herd on them to assure their effectiveness. But the quality engineering function goes far beyond a mere corrective action activity. Using advanced analytical tools which monitor product effectiveness, quality engineers detect trends and initiate action before a major problem develops. The Quality Engineering Historical Data Bank and automated reporting systems have been tailored to monitor the various aerospace systems, to monitor supplier performance, to publish supplier rating reports that aid in the selection of suppliers, and to make timely adjustments in sampling inspection plans. Once again, preventive action, not just inspection activity after the fact. This elaborate system of checks and balances goes even one step further at McDonnell. Casting an investigative eye over the entire Quality Assurance Division is the Quality Audit Department. In fact, any function which affects the quality of the end product is fair game for the audit investigators, regardless of the department or division in which it occurs. Quality audit personnel work closely with departmental supervisors to eliminate problems uncovered by periodic audit investigation. They are men with experience in many phases of the quality assurance program, and they are specially selected for their ability to contribute to the overall group effort. It is their job to understand management problems and to formulate and carry through improvements in the McDonnell team operation. Nationally recognized quality control organizations count many McDonnell management personnel as their members. Through these organizations, they contribute to technical advancement and coordinate quality assurance matters on an industry-wide scale. From this, we see that at McDonnell, quality assurance never stops. It begins with the birth of thousands of parts and components in plants all around the country. It continues with the arrival of these parts at the St. Louis plant. And from there, through the complex process of molding these components into finished products, inspection and quality go hand in hand. Vice President Hubert Humphrey put it this way during a visit in 1966.
I congratulate you on your performance. If there's one thing that this company stands for, it's excellence. And I surely salute you. You ought to have a permanent E above this company, not only for an award for your efficiency and your tremendous productive capacity, but for the excellence of your product and of your people.
When the phantoms are ready to try their wings, quality assurance experts are there to push them out of the nest. And when they return to Earth again, the men whose search for quality never ends are waiting to check and analyze and explore them again, even though the flights were near perfection. This is the secret of McDonnell Douglas quality. Not just inspection, but investigation and analyzation of the results. And from this, planning that will lead to an even greater assurance of quality from McDonnell Douglas.